This video is brought to you by 2046 Print Shop. Get 15% off with the link in the description. Hydropower may not be the new technology on the block, but this old school tech may have a few tricks left in it. With other renewables like wind and solar gaining momentum, is there still room for growth? Are there any downsides that hydropower has to address? And what about technology advancements? There's some really cool stuff coming our way. I'm Matt Ferrell. Welcome to Undecided. This video is part of a two-part collaboration with the YouTube channel Terramator. Terramator explores environmental and conservation topics and wants to inspire you to take care of our planet. Now, I'm doing a deep dive on the technology behind hydropower and where it's heading, and Terramator's video does a wonderful job covering the environmental impacts of hydropower, but more on that later. To give this some context to make it clear why some of the new technology coming up is so important, we should take a quick step back. For more than a century, humans have been using gravitational force of falling or flowing water to generate electricity at scale. Now, this shouldn't be news to anyone out there. During this time, there's been technological innovations with turbines and other alternatives to extract more power from the force of water to supply the growing energy consumption of cities, industries, and farms. The first use of hydropower was for mechanical milling by the Greeks thousands of years ago, but it wasn't until 1882 that the first commercial hydroelectric power plant started to operate in Wisconsin. And since then, water has been a powerful source utilized to generate electricity at large scale all over the globe. Now, while hydroelectric power is considered a renewable source since it doesn't reduce the quantity of water that flows through the turbines, there are environmental concerns regarding the dams needed for the process, but I'll get to that in a bit, as well as some of the cool technology trying to change that. Now, as I already mentioned, hydropower is by far the most widely used form of renewable energy in the world, accounting for about 17% of global electricity consumption. For example, in Europe, hydropower accounts for more than 341 terawatt hours per year, equaling about 36% of electricity generated from renewable sources. Up until 2019, it was the most extensive source of power among renewables in the US and Canada, accounting for almost 60% of generation. I'm pretty sure everybody out there is at least a little familiar with the basics of how hydroelectric power works, but in a nutshell, it always comes down to turning a turbine. The gravitational force of falling or flowing water is used to spin a hydraulic turbine that's coupled to a rotor of an electric generator. So when the water flows through the turbine, it spins the blades, creating the kinetic energy, which is converted into electric power by that generator. There are three main types of hydropower plants currently in use that are putting this principle to work. The most common type is storage hydropower plants, also called impoundment facilities. A famous example of an impoundment facility is the Hoover Dam in the US. In these plants, a dam is used to control the volume of water stored in a reservoir. When energy is needed by the electric power system, the massive volume of water that's being held back is released from the dam, which flows downwards to the turbine. Water stored in reservoirs like this provide flexibility for producing electricity during peak demand. Some reservoirs store a massive volume of water that's enough to produce electricity for months. Yeah, seriously, months. And they're typically designed as a multi-purpose system for controlling flooding, irrigation, storing water, and recreation. The second type of hydropower plant is run-of-river or diversion power plant. They may or may not use water storage, and in a run-of-river hydro project, a portion of the water flowing in the river is diverted towards hydraulic turbines to generate electricity, and then reunited back to the river. Typically, diversion power plants are constructed in mountainous regions to utilize natural water flow to generate more power. And while diversion power plants have a much smaller environmental footprint compared to impoundments, the downside is that they don't have energy storage or a buffer to pull from when there's a rapid increase in power draw from the grid. The third type of hydropower plant is pumped storage, which has a small storage reservoir. Now, these plants store energy by pumping water from a lower reservoir to a higher reservoir using cheap electricity in off-peak periods. Then, when electricity prices are high or there's high power demand, water is released back to the lower reservoir through the turbines to produce electricity. It's essentially a giant water battery that charges and discharges. According to the Office of Energy Efficiency and Renewable Energy, pumped storage installations account for about 95% of all utility-scale energy storage in the US. When you take all of those into account, there are more than 1,300 gigawatts of installed hydropower capacity globally. But how does it stack up to other power sources? And when evaluating this type of thing, it's not just how green or renewable it is, it's also how reliable, accessible, and affordable it is. It's well established that greenhouse gas emissions in hydropower are much lower than those in fossil fuel power plants, such as coal, natural gas, and petroleum. And according to the International Hydropower Association, if current hydropower was replaced with burning coal, more than 4 billion metric tons of extra greenhouse gases would be released annually into the atmosphere, increasing global emissions by at least 10%. Score 1 for hydropower. However, as I've talked about in other videos, even renewable energy has environmental challenges. Solar and wind have no or low environmental impact while operating, but the impacts caused by manufacturing and transportation to installation sites needs to be factored in. With solar panels, the main environmental costs come from manufacturing, installation, and disposal. And wind turbines share some of the same challenges, but also present additional risks for wildlife during operation. I have videos that explore both those topics in depth if you're interested to learn more. Now, hydroelectric power, unfortunately, also doesn't come out unscathed when considering environmental impacts. And one way to quantify those impacts is through a life cycle assessment, or LCA. Now, LCAs let you identify the most significant impacts and the stages to be considered for improvements. One specific LCA for a hydropower plant in Amazonia showed that the construction phase represented the highest contribution to environmental impacts. From things like the steel used in the turbines, the concrete in the spillway and penstock and powerhouse, transporting all of the equipment long distances also pointed to an increase in emissions. Much like other renewables though, the operation causes no significant impact as far as carbon emissions are concerned. But what about the million-dollar question? Literally, how much does it cost compared to other sources? The levelized cost of electricity, or LCOE, is a good apples-to-apples comparison between technologies. LCOE estimates take everything into account from building a facility to operating it for a specified period. It looks at things like capital costs, fuel costs, fixed and variable operations, maintenance, financing, and how much each plant type will be used. In one study from the EIA that explored power sources coming online by 2025, hydropower is about 32% higher in cost than onshore wind and 59% higher than solar. But when compared to offshore wind, hydropower is 56% lower. It also beats out coal, advanced nuclear, combustion turbines, and biomass plants as well, which makes it not only very cost efficient, but also a good, renewable, stable, and reliable power source. Even though the cost of manufacturing and installing other renewables has been decreasing, hydroelectricity still has many advantages. The versatility and storage capacity of hydroelectric power plants make them a great counterbalance to the intermittence of solar and wind, which really need energy storage to make them more widely viable. Compared to oil and gas, water is not subject to market fluctuations. Hydropower can be delivered quickly to satisfy peak demands, maintain the system voltage levels, and rapidly reestablish power supply after a blackout. Hydropower also has low failure rates and a long life cycle, all while producing tiny amounts of greenhouse gases. However, there are concerns about hydropower, mainly regarding dam construction and impacts on wildlife. Hydropower dams can have a sizable biological impact since the environmental footprint of these facilities disrupts a large area. Damming rivers affects local habitats and ecosystems and may lead to flooding, changes in water flow patterns, sediment buildup, and fish migration problems. But there are technological innovations being developed to make hydropower cheaper, shrink the size and scale to reduce the environmental damage, and increase the power capacity. But before I get to some of the cool new hydropower technologies at play, how about decking out your home or clothes with some awesome space or science-inspired prints? Now, I'm a huge fan of 2046 Print Shop, and I'm really excited that they're sponsoring this video. If you have any doubt that I'm a fan, I've got some of their prints hung up around my home, as well as a few of their t-shirts. Just check out some of the prints inspired by electricity, solar power, and yes, hydropower. Talk about synergy for today's video. And if you want credibility, 2046 Print Shop has done work for both NASA and SpaceX. Some of their prints are limited edition, handmade, numbered, and signed so they sell out fast. So if you or someone you know is into science, space, physics, or astrophysics, stop by 2046 Print Shop. They'll make a great gift for this holiday season, or just treat yourself. Seriously, I'm a huge fan of their work. So go check them out today at the URL below and get 15% off. Thanks to 2046 Print Shop and to all of you for supporting the channel. Now, getting back to the new hydropower technologies, one good example is Tidal Energy, which utilizes water movements of the ocean to produce power underwater. The gravitational pull from both the moon and the sun result in high and low water surges that are used to spin turbines placed on the ocean floor. Now, this is far less disruptive on the environment since you're not building massive dams or redirecting rivers. One company, CMAC Atlantis, is focusing on underwater turbines, which are very similar to wind turbines, but they can be much smaller due to the higher density of water compared to air. Now, a test prototype system that was installed in Strangford Narrows, Ireland in 2008 was composed of two 16-meter diameter turbines with a capacity of about 0.6 megawatts each. A wind turbine of equivalent power would have had a diameter of 40 meters. Now, while the Strangford Narrows project didn't perform as well as expected, it only produced 15% of expected capacity. It was only a prototype and did provide valuable information for future revisions. In fact, their latest turbine technology is a lot better. The turbines installed between the island of Stroma and northeast coast of Scotland during the Maygen project had an increase in capacity from 0.6 megawatts to 1.5 megawatts. That's nearly 3 times more powerful with almost the same 16-meter diameter turbines that were installed in Strangford Narrows. You can also find a good example of tidal energy in the US with the Roosevelt Island Tidal Energy project, which Verdant Power has been running since 2002 in the East Channel of New York's East River. It's currently in its third phase of testing, which includes a commercial pilot scale build-out. This project will occupy an area of 21.6 acres and is going to be the world's first grid-connected array of tidal turbines. New York has several good sources for generating tidal power like the East River, St. Lawrence, and Niagara Rivers. Overall, the state has the potential to generate an estimated 500 to 1,000 megawatts of power from kinetic energy. While it's a clean, compact, and predictable power source, tidal does have some shortcomings. It lacks thorough research, and there are concerns about electromagnetic emissions impacting marine life, and the construction costs are still high. With all the projects going on right now, though, we should be starting to get some answers about the future viability of tidal technologies. But it's not just new methods of generation, we're also seeing innovations for a core component of hydropower, the hydraulic turbines. Turbulent, a company from Belgium, recently produced their eco-friendly turbines for run-of-river applications. Turbulent's Vortex hydraulic turbines range in power from 5 to 70 kilowatts and are a compact and low-noise submerged design for both on-grid and off-grid applications. Prefabricated parts are installed next to the water, and then the excavated space is backfilled after the installation. The turbines have curved blades and operate under low RPM, so the low pressure in the turbine make it fish-friendly. Turbulent implemented a project in Green School, the world-famous sustainable school located next to the Ayung River in Bali, Indonesia. The 13-kilowatt Vortex turbine has benefited more than 700 students, teachers, and staff. The company has other big projects ongoing too, like a micro-hydropower plant in Taiwan that will provide 600 kilowatts of continuous power. Another breakthrough for water power energy developed by Rotor is a technology that converts 50% of energy capacity from slow-moving water into electricity. Water that's moving at about 5.5 miles per hour can generate power at a cost of about 5 cents per kilowatt hour. At speeds of 4 miles per hour or slower, that price can get up to about 15 cents per kilowatt hour. As we've seen in the last few decades, the world is transitioning to a low-carbon future where renewable resources are supplying a larger portion of our electricity needs. After providing electricity for more than a century in all parts of the globe, it's not surprising that hydropower's growth has been decreasing compared to the quick spread of other renewables. However, due to the intermittent nature of solar and wind, it's impossible to ensure a cost-efficient grid stability with those alone. So the old workhorse of hydropower is still essential for the transition to low carbon, but we need to keep looking at newer technologies and approaches that can minimize the environmental impacts. And to learn more about these impacts, be sure to jump over to the YouTube channel Terra to see more about that in their part of this collaboration. You'll find a link in the description, and you'll learn a lot more about some of the surprising downsides to hydropower and what it means for the areas affected. And it also helps to give some context as to why some of these newer technologies and research are so important to the future of hydropower and the environment. Now jump into the comments and let me know what you think. If you like this video, be sure to check out one of the ones I have linked to right here, and be sure to subscribe and hit that notification bell if you think I've earned it. And as always, thanks so much for watching. I'll see you in the next one.